Let's demystify a core Linux mechanism you probably use every single day, the pseudo-terminal.
Yeah, how does a program talk to another like it's a real terminal? That's the whole point of a PTY. You use PTYs constantly in tools like SSH, tmux, and container consoles. They're everywhere. But hey, to really get why they're needed, let's see what happens when they're missing.
Yeah, pretty much everything breaks. Interactive programs just expect a real terminal, not some simple pipe.
So this is the core problem. How do you make a program believe it's attached to a real terminal? And the answer is the PTY. It's this brilliant kernel-level trick that creates the illusion of a terminal.
See, a PTY is actually a pair. There's the master side for control and the slave side for the magic show.
The program, like your shell, connects to the slave side, and it is completely convinced it's a real terminal.
Meanwhile, the manager program, like an SSH server, connects to the master side to send and receive data.
A great way to think about this is the puppeteer stage. Let's see how it all works. Okay, so we've got three actors here: the program itself, the manager, and the kernel providing the rules. The slave side is what the program sees. To it, this is a real terminal for input and output. And the master is what the parent sees. It can feed it keyboard input and grab all the screen output. And you see this everywhere, in your terminal emulator, SSH, tmux, even session recorders. This is the real key. A pipe just says, here are some bytes. A PTY says so much more. What's terminal behavior? Things like job control, signals from Ctrl-C, and window size changes. So, the one core idea? A PTY provides a terminal environment, not just a data pipe. That's everything. PTYs let software virtualize the relationship between a user and a terminal. That's why they're so foundational.